Welcome to the Mastering RxJS series. In this series, we're going to take a look at working with the RxJS JavaScript library. My name is Eric Green, and this video is brought to you by Wintellect Now. So in this particular course, Getting Started, we're going to take a look at an overview of what RxJS is. Then we're going to take a look at setting up a development environment so we can try out RxJS. We'll talk a little bit about creating observables and some of the ways in which you can do that, and we'll do some demonstrations. Then we're going to talk about error handling with observables. Then we're going to take a look at how to manage observable subscriptions. We'll take a look at the idea of an observable completing, as well as how to unsubscribe. And then finally, we'll talk about multiple subscriptions, what actually happens when you subscribe, and what happens if you try to subscribe multiple times. To get started, we first have to understand the problem that RxJS solves. And before we dive into the details of RxJS, let's talk about some of the other ways we've tried to solve this problem in the past to kind of help us relate it to where RxJS kind of fits into the big JavaScript picture. Now, JavaScript itself as a language is well known for its non-blocking nature. Essentially, JavaScript itself is actually single-threaded. And anytime you try to access some type of external resource, when you go to access that resource, JavaScript is non-blocking. What that means is it follows the asynchronous pattern of handing off your request to the surrounding environment, and then JavaScript moves on to the next task. Now, this type of approach to coding is a little bit different than what people who are Java developers or C# developers might be used to. And one of the great challenges in becoming a JavaScript developer is mastering the coding patterns that are used to manage this. Now, out of the box, JavaScript supports something called callback functions. Callback functions allow you to basically initiate a call to some type of surrounding resource, pass it a callback function, and then that resource takes control of the call, accesses, does whatever it's supposed to do. Then when it's done, it takes the data that comes back from it and then invokes that function. Well, callbacks are simple enough to use. The problem, though, is when you start having to coordinate multiple resource operations or multiple asynchronous calls, callbacks start to become a problem. One of the challenges with them is that they're actually limited by lexical scope. That means the actual callback function has to be defined, the source code for it, inside of the function that originally made the call to the resource. When trying to do error handling and managing complex asynchronous scenarios, this becomes a real pain. Well, the next built-in way to JavaScript to deal with asynchronous operations is to use promises. Now, promises have been around for a long time, but in ES 2015, they were actually added officially to JavaScript. And promises are great because they allow us to escape some of the limitations of lexical scope in terms of writing our code to manage asynchronous operations. The problem, though, is that promises have one big, huge limitation. A promise can only resolve once or reject once. You can't resolve it multiple times, you can't reject it multiple times, you can't resolve it, then reject it, what have you. The reason this becomes an issue is not so much when doing things like making a REST service call or maybe doing set timeout, but imagine a scenario where you have a stream of asynchronous data. Think of a stock ticker. Right, so you have a WebSocket set up between your web browser and your server. Over the WebSocket, you're going to receive continuous updates to the stock price. Promises are not good for that situation because they can't resolve multiple pieces of data for the same asynchronous operation. However, when you work with something like a WebSocket, that's a very common thing you want to be able to do, be able to handle that stream of data. So to help us with that, we could use something called generators along with promises. The problem is generators with promises is kind of a pain to work with. The syntax is not easy and it's kind of conceptually difficult and hard to understand. So to help us solve this problem, we can use something called an observable. An observable can handle a stream of asynchronous data. Now, observables, unlike callbacks, promises, and generators, are not actually built into JavaScript. Instead, they are provided by a library called RxJS. Now, RxJS was originally created by Microsoft, and it's used in all types of different situations. It can be used for traditional web applications, but you could also use it when doing Node application development too. Now, the underlying idea behind RxJS is something called ReactiveX programming. And ReactiveX programming is not limited to JavaScript. There's actually C# libraries, Java libraries, Python libraries, a whole host of other libraries that actually make use of this ReactiveX programming pattern. RxJS is just the implementation of this pattern in JavaScript. Now, the current version of RxJS at the time of this recording is actually version 6. And so we'll be looking at things from a version 6 perspective. Some things have been deprecated from the past. We'll mention a few of those throughout the course, but we will be teaching this from the perspective of version 6. So observables are the way in which we're going to be managing this stream of asynchronous data using the RxJS library. Now, a lot of folks don't realize just how many sources of asynchronous data streams there really are. For example, data received over WebSockets like a stock ticker. Events such as button clicks. Each time you click that button, it fires off another asynchronous event. Well, that event object is asynchronous data, and clicking it multiple times results in a stream of asynchronous data. You could also have model data as it changes over time. Think of Redux. When you're working with a Redux store and the actual data in the Redux store changes over time, that changing over time of your data is an asynchronous stream of data. Receiving messages from web workers. Even the simple function setInterval. It runs on a set interval. Well, every time it runs on each interval at the end of each time period, that's another source of an asynchronous data stream. You can even take non-streaming asynchronous things like REST service calls, wrap them in observables so that you can then connect them to other observables. You also can write code that will convert observables to promises and promises to observables as appropriate. In fact, the popular UI framework Angular actually uses observables to manage all of its asynchronous operations. Everything from button clicks to REST service calls. Now, there's 3 important objects you want to be aware of when working with RxJS. The first one is called the observable. This is actually the data source of the asynchronous stream of data. This is going to wrap that asynchronous operation, receive the data through an observer, and then be able to set up subscriptions to that data. Observables can do things like transform, filter, and even throttle the data being emitted. Subscribers are the things that are actually listening to the data source. So for example, if you want to receive the button clicks or you want to receive the actual WebSocket information, you can subscribe to the observable. You're subscribing to a stream of asynchronous data. As part of subscribing, you'll be notified of new data. You'll be notified if an error occurs. You'll also be notified when the actual stream has completed. Now, if the stream does not complete and you want to disconnect from it, then you need to unsubscribe, and we'll talk more about that later. Then finally, we have the observer. The observer is kind of part of the creation of the observable. It actually wraps the asynchronous operation and provides you the object necessary to emit data, to emit errors, and then finally mark the stream as being complete. In fact, the observer is actually implemented as a subscriber. And the observer in the observable is actually the same object that's used as the subscriber when subscribing to the observable. Now, RxJS is very, very, very large. We're going to have multiple videos in this series. We still won't cover every single feature. But from the perspective of this particular course, we're going to be looking at how to create observables and do some of the basics of managing the stream of asynchronous data. Now, before we can actually get started using RxJS, we actually have to have a development environment. Now, keep in mind, RxJS is not limited to like coding web applications. Like, for example, if you were to fire up an Angular app, you'd have access to RxJS because it's actually used as part of Angular. But you can actually use it as a separate library in any web-based or Node.js-based application written in JavaScript. So what we're going to do is we're actually going to use a tool called Parcel. We're going to do this from the perspective of a web application, but instead of tying us to something like React or Angular, we're going to use Parcel, which will basically fire up a web server that's configured by Webpack, and then allows us to reference JavaScript files from our index.html file, And then in those JavaScript files, we can then put in all of our RxJS code. Now, what's cool about this is that because we're using Webpack and Babel to transpile all of our code, both of which are provided by Parcel, we can use all the modern, latest, and greatest JavaScript syntax, including ES 2015 modules. Now, to actually use Parcel as well as install RxJS, you will have to have Node.js and NPM installed. I recommend you head over to nodejs.org. You can simply download the latest version of Node and install it if you don't already have it. You do want to make sure that you have version 8 or later of Node. Now, for file editing, you can use any editor you would like, but I'm going to recommend that you use Visual Studio Code. That's the one I'll be using for my coding demonstrations. Visual Studio Code is a great editor. It's totally cross-platform. I'm actually recording this on Linux, but it runs on Linux, Mac, and Windows, and it's just a tremendous, tremendous editor. It's probably, from all of my teaching and stuff that I do, it's probably the most popular editor out there for people who are writing modern JavaScript applications. Now, to get up and running, here's a quick little overview. First of all, install Node.js version 10. You can probably get away with version 8 if you already have that installed, but if you're installing it brand new, go ahead and grab the latest, which as of this recording is version 10. We're going to use NPM to install Parcel. The actual package name is called Parcel Bundler. That will install our web server, Webpack configuration, and allow us to set up our web project. Then we need to create a project folder. So we're going to create a folder here called Explore RxJS, and then inside that we'll put all of our project files. Open this folder in the editor of your choice. Like I said, I recommend Visual Studio Code. Create 2 files, one called index.html, and then create a folder called JS, and inside of JS create a file called app.js. And I'll show you what content to put in those files once we do the demonstration. So for step 6, what we're going to do is we need to actually fire up our web server. So from your terminal window within the project folder, we're going to start up our web server by typing in parcel space and the name of our HTML file, which in this case is index.html. Once we do that, we can open up our Chrome browser and load up localhost 1234. And then once we do that, we want to open up our developer tools, which you can open with Control-Shift-I or using F12. And then once those are open, go ahead and click on the console tab so you can view the console in your web browser. Almost all of the code that we're going to be running in our demonstrations is all going to just be outputting stuff to the console. This isn't really about building web applications. It's more about understanding RxJS within the context of JavaScript, and we're using the web browser really as just a JavaScript execution environment. So let's do a demonstration now of creating a project using RxJS. Let's go ahead and get started here with setting up a development environment to do our RxJS coding. You'll need to have Node.js installed. As you can see at the time of this recording, the current version is 10.9 and the LTS version is 8.11.4. Go ahead and make sure you've got at least version 8 installed of Node in order to be able to run this project. You'll also need a text editor. Here I've got code.visualstudio.com. I recommend this editor. This is a great editor for doing JavaScript coding. It's probably the most popular editor out there for folks who are writing modern JavaScript applications. It's got lots of extensions. It's totally cross-platform, works on Windows, Mac, and Linux. It's a great tool. Then, of course, we've got Parcel. This is going to be our blazing fast, zero configuration web application bundler. So we're not going to be like focusing in on React or Angular or anything specific like that. This will just give us a nice little environment to run our JavaScript code. So let's go ahead and switch over to our editor now. So what we're going to do now is we're going to install our Parcel bundler. So we're going to say npm install -g parcel bundler. And this will install it globally so we can just use it wherever without actually having to install it to be able to run our little application. All right, excellent. So now that we've got Parcel bundler installed, let's go ahead and create ourselves a folder. Make dir explore RxJS. We'll go ahead and change into that folder. There we go. Now we need to go ahead and open this folder in our editor. However it is you open folders in the editor of your choice is what you can do now. For me, I'm going to say code dot, and that'll open up Visual Studio Code in this particular folder. So here's my Visual Studio Code editor window. Now inside of here, I'm going to go ahead and create the two files, the index.html and the app.js. So we'll say new file, index.html. At the type, simply just do doc type, HTML at the top here. And then we're going to come into here and we're going to just put a little message, just say hello world. Whoops. And then down here we're going to add a little script block, js/app.js. And then we're going to come over here and create a folder called JS, and inside of it we'll put a file called app.js. There we go. And then inside of here just say console.log hello world. And all we're going to do is just load this thing up to verify that everything works right. Now down here I'm going to close this window. We're going to actually reopen this, but I'm going to close this first. And then what I'm going to do is I'm going to open up my terminal window here inside of Visual Studio Code. I can do that by either going to View and clicking on Terminal, or I can do Control backtick when the backtick is the quote next to the number 1 on your keyboard. So I can go to Control backtick. Then inside of here I can say parcel index.html. This will actually fire up the web server. You can see localhost 1234. It creates a bunch of folders here for the distribution folder and the cache. So now if you come back over to your web browser and say localhost 1234, you should see hello world. If you open up your developer tools, you can do that by doing Control-Shift-I or F12. You can also open them up by coming over here to the 3 dots, going down to More Tools and clicking on Developer Tools. Now you notice we do have one error. It's trying to load the favicon. We don't have a favicon, so just reload the page and that'll actually go away. It'll stop trying to download it after the initial download. Now our last step that we need to do here is actually we need to install RxJS. So we're going to come into here and you can stop your web server by hitting Control-C, and that stops it. Then we're going to say npm install RxJS. This will actually download RxJS. It'll put it here in a node modules folder. So far so good. Now you can go ahead and fire your server back up, parcel index, and we are all set to get busy with some RxJS programming. In order to get started with observables, we first need to know how to create them. Now it turns out using RxJS there's lots of different ways to create observables, but it primarily boils down to 2 approaches. One, you can actually use the create function on the observable object to actually create the observable. So if you wanted to do like a fully custom, you have some type of custom asynchronous operation when you want to wrap that in your own custom code, that's when you would use that. But there's also numerous helper functions, which in some cases just simplify the same asynchronous patterns that are used over and over again, such as connecting in a set interval. And in other cases, you can actually take non-observable values and actually wrap them in an observable so you can connect them up with other observable operations. Now, to work with RxJS, you first, of course, have to install the RxJS package. Then we have to import. Now, to actually import the observable object so we can access create, we can simply say import, open curly brace, observable, close curly brace. And that's because RxJS makes use of the whole named import system so we can pull in only the parts and pieces that we need. If we want to make use of some of the helper functions like of or interval, we can include those in the curly braces instead of directly referencing observable. Now, to create an observable using the actual create function, what we're going to do is call observable.create, and we're going to pass a callback function into it. That callback function, when it is invoked by the observable API, will actually pass in an observer object. This observer object is what we're going to be using to actually trigger or emit data from the observable. Now, when we actually subscribe to the observable, this observer function then gets executed. In this case, when it gets executed, it's going to actually start firing off set interval. And every 500 milliseconds or so, it's actually going to output a new counter value. Now, as you could imagine, setting up observable with set interval is probably a pretty common thing to do. So there's actually a special helper function called interval that you can import from RxJS to make it easier to set this up. Now, to actually consume the observable, we have to call the subscribe function. On the observable that we've created, that object, we can say .subscribe, pass in a callback function, and then the values of the observable as they are emitted will be passed into this function and it will be invoked. Now remember, unlike promises which only resolve or reject one time, this function will be executed multiple times. Each time a new value is emitted from the observable, this callback function is going to be executed. So in the case of our nums observable generating a bunch of numbers, each number that we generate is going to cause this callback function passed into subscribe to be executed. Now, another common thing that we can set up with observables is actually to listen to events from web browser objects. So in this case, we have some HTML code with a button being defined, and we want to have an observable wired up off of this button so that each time we click it, it emits an event from that observable. Well, we can actually use the from event helper method. Now, of course, you could code this up with observable.create, but from event is really nice. You basically give it a reference to the actual object whose event you want to bind to. So here we're going to use document.querySelector, and we're going to look for the button with an ID of clickme. And the second argument you pass into from event is the actual name of the event that you want to connect into, in this case, click. Now what we can do is we can subscribe to the observable, and each time the button is clicked, it'll actually run this function saying clicked me was clicked. We can use this same approach for working with WebSockets. A WebSocket is nothing more than a web browser object. We can simply set up our WebSocket, set up our from event to hook into our instance of a WebSocket and the message event. And then whenever messages come through, we can simply just take the data, parse it out, access our payload information. Now in this case, we're going to set this up so that we're going to open up a WebSocket connection and we're going to send an initial message to the server. We have a special little test server that sends back data to us. And then when that data comes back, it'll be processed by the observable and we'll be able to see it outputted through the subscribe function. Another thing you can do is you can have a bunch of fixed values. So you could actually have one value that you want to wrap in an observable, or you could have a series of values. In this case, we have a series of values, 1, 2, 3, 4, and 5. By wrapping them in the of function, it produces an observable, and then when you subscribe, each number will be emitted separately. Now they are emitted immediately, okay? But they're not emitted as one group. They're emitted as five different pieces of data. It's just they all get fired one right after the other. There's no delay or anything like that. This is quite similar to using something like promise.resolve or promise.reject static functions for basically taking a non-promise value and wrapping it in a promise. Well, here we're taking basically a non-observable set of data and wrapping that in an observable so we can connect it into other observable API functions. Now, one thing I want to mention here about the of function, you'll notice this in the slide, but you'll also notice this in your editor. Of is actually a reserved word in JavaScript. It's part of the for of loop that came out with ES 2015. So when you use the word of as a function, it's totally legit. You can do it like we are here. But the syntax highlighting in your browser will sometimes change it to make it look like it's a keyword, like it's doing right here. So if you take a look at the import of or the const nums equal to of, the of in both of those cases is actually colored blue, which is actually for a reserved word like const or from or import. But it's because we're using an of function even though there's actually an of keyword in JavaScript. Let's do a demonstration now of creating observables. So let's go ahead and take a look here at how to actually create an observable. We're going to start off first by looking at the create function. So here in our app.js, we're going to go ahead and delete hello world. And we're going to say import observable from RxJS. Now, if you don't remember to type in the word observable, you can always simply put RxJS first, and then come in here in your editor, if it has supports IntelliSense, type in observable, and you'll see that you'll get the actual observable listed there. And then you can pull that in through your code completion. Now, let's go ahead and set this up. So we're going to say const nums equal to observable dot create observer arrow. There we go. And then what we're going to do is we're going to say let counter equal to 1, and we're going to build our own incrementing counter for this. So we'll come into here and we're going to say const handle equal to set interval and then we're going to have this run every 500 milliseconds. Now what we want to do is we want to take this observer and we want to say observer dot next. And we're going to output the current counter and then increment it by 1. So now what's going to happen is we have this observer function which wraps the asynchronous operation, and then inside of the callback of the asynchronous operation we're referring to the observer object and calling next to output the next value. So now we can subscribe to this. We can say nums.subscribe. And then here we can say num. And we can say console.log num. This will actually output each number that comes through. So we'll save that, come back over here to our web browser and reload. And now we get 1, 2, 3, 4, 5, 6, 7, so on and so forth. So each time we get a new value, this function is running. So let's come into here. We could say console.log invoked observer function. Put a semicolon there. Now I'm going to comment out nums.subscribe here for the moment, and I want you to observe something. Reload. You will see nothing happens. Unlike promises, where when you create the promise object, the function passed into it is immediately invoked, with observables, the observer function is not invoked until you actually subscribe. So now if I come back over to here and I subscribe, in fact I'm going to say console.log subscribing, and then here we'll say console.log received a new value. Take a look. So we have subscribing, then invoking the observer function, and then receiving a new value. So you can see the subscribing act is what actually triggers that observer function to run and then brings the whole thing to life. So that's how we can create an observable using the create function on the observable object. Now let's go ahead and take a look at how we could use a helper method to do this same thing. As you can imagine, setting up a set interval would be a pretty common thing to do. So there's actually a helper function available to us in the RxJS library. And what we're going to do is we're going to just kind of collapse this down here a little bit. And let's go ahead and take this and comment that out. Then we'll say const nums is equal to interval, interface, interval. And we'll set the interval here once again to 500 milliseconds. So go ahead and save that. And we can reload. And here's our values coming through once again. The only thing that didn't output was the actual running the observer. And the reason why that didn't do anything was because with our interval here, those details of how the observer is implemented is hidden from us. We're simply just calling the helper function and specifying the number of milliseconds, and then it takes off from there once we call subscribe. So now that we've worked here with the observable and interval, let's take a look at the from event helper. We're going to come over to index here and we're going to create an actual button. Type equal to button. Click me. And then we'll say ID is equal to click me. So now let's come back over to app.js and let's go ahead and let's import the from event helper. We'll just comment out this code we did a few moments ago, and we're going to kind of scoot this down here a little bit. Now what we're going to do is we're going to create an observable from this from event helper. So we're going to say const button observable is equal to from event, and then we're going to say document.querySelector hashtag click me, comma, and we're going to hook into the click event. Great. So now we've got our observable. We're going to subscribe to this, and we're going to receive an event object each time the button is actually clicked. So we'll say console.log clicked. So now this is going to hook into the button. We have our ID selector here. If you come back over our click me ID, and then here we're going to hook into the click event. We can save that. Head back over to our web browser here and reload. Now watch what happens when I click me. It outputs clicked. So each time I click that now, it's actually going to run pass a new piece of event data through the observable and run this function. Now if we want to access that event data, we can do so through the actual parameter here. And we could say console.log EVT for the event and reload. Then click on click me, and you can see we get our mouse event for each time that we actually click the button. So this is another way of hooking into your web page and actually using observables is with these events that occur on these web browser objects. Now we had mentioned earlier in our discussion that a common use case for using observables would be something like a WebSocket where you get this stream of asynchronous data over the network. So let's go ahead and take a look at using this from event with an actual WebSocket. So what we're going to do here is we're first going to install an actual mock WebSocket server. So we actually have some WebSocket data to work with. So come down to your terminal and go ahead and cancel out of your parcel index.html by hitting Control-C. Then we're going to say npm install, and we're going to say fake-web-socket-server. And this is actually going to provide us a fake WebSocket server that we can use to get some data from. So we'll do install. This will download the fake WebSocket server. We can actually start it up by just simply saying npx fake WebSocket server. And our mock WebSocket server has been started. So now what we need to do is actually use WebSockets to talk to the server and then wire up the message event using the from event helper function. So we'll come into here and we're going to say const WebSocket is equal to new WebSocket, and we'll say WS, that's the WebSocket protocol, local host, this is running on port 8080. Then we'll come into here and we'll say const nums equal to from event, and then for this we're going to actually pass in our WebSocket object. We'll pass in the name of the event that we want to hook into, which is message. And now we want to subscribe to it, so we'll say nums.subscribe. And we're going to be getting back a message object. So we'll say message arrow, and then console.log message.data. And this will actually have the data that we're getting back from the WebSocket server. Now what we're going to do is we're going to come into here and we're going to go ahead and wire this up so that when we open the WebSocket, we're going to send it a message to then tell it to start sending us some data. So WebSocket.addEventListener, open, there we go, and then we can say WebSocket.send JSON.stringify, and then we're going to pass into it type :counter. And this is one of the operations understood by the fake socket server to be able to send us back some data. So we'll take that and we'll save it. And we'll need to open up a second window here to actually run our web server again, since we're running our mock WebSocket server on this terminal window. So I'll just open up another one, and I'm going to say parcel index.html. Come back over here, reload my page. See, there's my payload coming through. and then down here at the end it's done. So it actually finished doing all of the processing. But you can see we actually got this data coming through on the WebSocket using our observable mechanism here. In fact, we could transform this data if we wanted to. We could actually come into here and we could say json.parse message.data, and then off of message.data simply reference the payload property. And now when this thing reloads, we actually get, oops, looks like our WebSocket server died. Let's go ahead and fire that back up again. Reload, and now we get 0, 1, 2, 3, 4, 5, 6, 8, 9. In the operators video, we actually go through and show you how you could take this and actually transform the value. We'll do a quick example of it here, but we go into it in more depth in our operators video. But we'll pull in the map function here, RxJS/operators. And then what we're going to do here is we're actually going to say dot pipe, and then inside of here, whoops, we'll just use a map function, and we're going to actually get our message back. And then what we're going to do is we'll take all of this right here and we'll transform it, which will then give us back our actual number. And then down here I'll just replace message with num, because we're going to be getting individual numbers. Num : num. There we go. Reload. Whoops. Start our socket server again. Reload. There we go. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See how that works? So now we're doing a little bit of transforming of our data, but we'll take a deeper look at how we can do various operations on our data in the operators video. So there's an example of using WebSockets and observables to bring in an asynchronous stream of data. For our final one here, we're going to actually create an observable just off of some fixed data. So let's take our WebSocket implementation here, comment that out. We'll come up here and we're going to go ahead and bring in the of function. And then we're just simply going to say const nums of 1, 2, 3, 4, 5. Now in this case, it's going to basically produce an observable, emit the 5 numbers individually, but it's going to emit them all pretty much immediately, like in order, but it's going to go super fast. So we'll say nums.subscribe, and then we'll have our num console.log num. There we go. Come back over here and reload, and you'll see it comes out almost immediately. But they are emitted as 5 different numbers. So it's not like it pushes all 5 through at the same time. It does do them in order, but it does it immediately. So like we mentioned before, the of is useful when wrapping non-observable data in an observable so you can then combine it with other observables. Now, just like promises, it's possible with observables for something to go wrong. We could have an error. In the world of promises, we call this a reject. In the world of observables, we just call it emitting an error. Now, when you go to emit an error, it actually causes the observable to end, right? So it's not like you can emit an error and then emit the next value. Once you actually emit that error, that observable comes to an end, but you can actually handle that error. Now, to emit an error, we're going to use the error function that's available on the observer. So you can see here, if our counter is greater than 5, we're just going to output an error just for the sake of outputting an error. So observer.error, and then output something called something went wrong. To actually handle that error, we're going to pass in a second function to subscribe. So the second argument to subscribe is a callback function that allows us to handle that error, and then you can do whatever we want to do with the error in terms of maybe some logging, outputting something to the screen, what have you. Let's do a demonstration now of handling errors in observables. Let's go ahead and take a look at how to work with errors in observables. I'm going to make a copy of our app.js file here and paste that there. Just rename that to creating. And then we'll take our app.js file here. And we're going to go ahead and just switch this back to using a plain old regular observable with the create function. And there's no need for us to retype all of this out. We'll just use this piece of code right here. Great. And let's comment. Let's actually delete that. Okay, cool. So now we've got our app.js set up here. If we reload this, you can see we've got all of our functions and stuff running. And what we're going to do is we're actually going to set this up so that we're going to throw an error. So we're going to come into here, and we're going to say if counter is greater than 3. Then we're going to throw an error. So we're going to do observer.error greater than 3. We're also going to go ahead and clear our interval and pass in our handle for that. So come back over here and reload. So now we have this uncaught error which occurred. Notice it stops the entire process. In fact, if we had not cleared the interval, let's say we didn't clear it, and we reloaded, you'll see we have an error and no more values continue to come through. Is the interval still running? Yes, it is. All right, is it still going through and running this? So as you can see, we're getting an error, but no more data is coming through. Even if we came into here and said equals, and so we came down here and said, you know, console.log sending next data, right? You'll see we're sending next data, but the data never comes through. We never receive a new value. So in this case, we're still getting all the way down here. We're still calling next, but because this error occurred, nothing else is coming through. Now we can actually handle this error inside of our subscribe by having an error function. And so we'll come into here and we'll say console.log. We handled the error. Console.error. And there's our actual error. So now take a look. Now we actually did handle the error. It's not uncaught anymore. But notice, even though we're still calling the interval over and over again, still no more data is coming through. So coming back over to here, we'll go ahead and uncomment our clear interval. So it actually clears the interval. And then reload again. And now, there we go. So it ran it one more time down here. But you can see we are now handling our error. It's very important you handle errors when doing any type of asynchronous operation. It's always possible that things are going to break. And so if they do break, you want to make sure you handle that and log things out and stuff like that so that you can go back and fix that later or research what the problem was that occurred. A really important part of working with observables is understanding how to manage your subscriptions. To understand what it means for an observable to complete or come to an end versus an observable not completing or not coming to an end or wanting to unsubscribe from it before it comes to an end. Now, observables can produce data for a definite or indefinite period of time. For example, you could use an observable to make a REST service call. You're only going to get one piece of data back. Once that REST service call completes, you're done. Your observable has completed. You're finished. However, you could be pulling in stock ticker data. Well, stock ticker data is going to run all day long. Maybe at the end of the trading day, we could say the observable has come to an end, but what about after hours trading? Maybe it's possible, like with currency trading, where the actual currency trading never actually really ever ends. So in those situations, you could have an observable run for an indefinite period of time or run for a very long period of time, and you might want to unsubscribe from it before it actually comes to an end or if it never comes to an end. Now, if an observable does complete, you do not have to unsubscribe. So if the actual observable finishes up and it completes itself, you do not have to go through the process of unsubscribing. It will unsubscribe for you. Which means, for example, if you use observables to make REST service calls, you don't have to unsubscribe from the observable after you make the call. However, if the observable never ends, or you want to leave it before it finishes or before it completes, then you will have to unsubscribe from it to ensure that you don't have any JavaScript memory leaks. You don't want to have any functions having references to them, any callback functions with references after you're done using the observable, because that'll just eat up memory, and that memory won't be cleared up until you actually unsubscribe. So you want to be clear about whether or not you're working with observables that are going to actually end and complete, or they're not, or you want to unsubscribe earlier. Now, to actually complete the observable, you can call the complete function on the observer. So when you say observer.complete, that will actually complete the observable. You cannot pass any data. No data is passed through this complete call. The third argument that you pass into subscribe will be your complete function. So if you want to run some type of logic, just once the observable has completed, as part of your application, you can. You don't have to. It'll be automatically unsubscribed as a part of that complete process. But if you want to run some code once it's all done, you're more than welcome to by passing the third function into subscribe. Now, let's say you have a scenario where you have a long-running observable that you want to leave, or one that really never does end. You actually have to unsubscribe from it. Well, when you call the subscribe function to subscribe to an observable, that function actually returns back to you a subscriber object. On that subscriber object is an unsubscribe function that you can call if you want to unsubscribe early from the observable. Now, when you unsubscribe from an observable, that will take care of that memory leak problem, but it does not trigger the execution of the complete method. So if you had registered a complete method as part of your subscription, just because you unsubscribe from it does not fire off that complete method. That complete function only fires off if the observable itself actually said, hey, it's complete. Let's do a demonstration now of completing and unsubscribing from observables. Let's go ahead now and take a look at how to manage our subscriptions when it comes to these observables. So let's make a copy here of our errors file and paste that like that and rename that to errors. Okay, so what we're going to do here is we're going to set this up so that our observable will eventually complete. So instead of throwing an error, we're actually going to wait till the counter gets to 5. And then we're just going to say observer.complete and leave it at that. And let's go ahead and clean up a few of those console logs. We don't need all of those. Now, what we're going to do is actually not 35. Let's make that 5. There we go. Come back in here and reload. So now our data is coming through. And you can see once we got to the 4 here, it actually stopped. So based upon counter being equal to 5 and the way the clear interval works, it cleared it and it stopped it here at 4. Now, we had no way of knowing that this was done. We had no way of knowing that complete was called. I mean, we stopped receiving data, but how do we know we're not going to get, data in the future, what have you? So what we can do here is we can actually wire up a function that will be called when everything is complete. So console.log, the observable is complete. There we go. So now we can reload. Take a look. So the observable is complete. So if you want to run some code once everything is completely done, you can do that by registering this third function over here, and now everything is complete. Now let's say we actually removed this code and commented it out, and we let this observable basically run forever. Well, we can actually get a subscription object here. So there's our subscription. And then down here, what we're going to do is we are going to say set timeout, and then we're going to set this to be for 5 seconds, and then we'll say subscription.unsubscribe. Reload. So it's going to go for about 5 seconds, and then we're going to unsubscribe, which we did. take a look. It stopped here at 10. So if we went to 5 and we're outputting it every 500 milliseconds, we should get about 10 values, which we did. But you will notice that it did not call the complete function. And that's because the observable did not complete. In order for it to complete, the observable itself must trigger the complete function. If it doesn't, all we did was unsubscribe. Now the reason we had to unsubscribe was this thing was never going to complete. So for observables that actually do complete, once they do, you do not have to unsubscribe manually. You will be unsubscribed automatically. But for observables that never end, or you want to leave it before it ends, then you have to make sure you call unsubscribe, and that will properly clean up things. Now, of course, that doesn't necessarily clean up the inside of the observable. We didn't go in here and actually unregister our set interval operation. But we have unsubscribed ourselves these callback functions from our subscription. So let's take a look at a more practical example of this. Let's utilize that WebSocket that we had created earlier. So we'll come back over here to creating, and I'm going to grab the WebSocket code that we had. Just copy that real quick. And we'll just take this code here and just kind of copy or comment it out. And we'll paste, copy, paste, there we go. And we'll pull this out here. Let's go ahead and uncomment our WebSocket code. Now, we will notice that if we take a look at our actual data that's coming back from our WebSocket and reload this, we are actually getting a done property. Make sure our socket server is running. We are actually getting a done property here. So we could actually come into here and we could actually check for this done and then use that to call complete. So coming down to here, I'm going to pass null for the error function, but then we'll have ourselves a complete function. And right now, if you run this, you will see it's not going to ever say complete. Yes, the WebSocket server stopped sending us data, but we never notified the observable that we had completed. So what we'll do is we'll come into here, and we're going to use a special operator called take while, which we talk about in more detail in the operators class. Using operators with RxJS is really an essential part. We're trying to focus here just on the creation, error handling, and how these things actually execute. But using operators is really essential to doing anything practical or useful with RxJS. So we're going to say take while, and then inside of here we're going to put a predicate function. So we're going to have our actual number that's being passed through, actually our actual message data that's coming through. And we're going to say data, and then we'll come into here and we're going to say data dot done, or not done actually. So while the data is not done, we're going to continue to take data, but once it's done, the take while will then trigger the complete and saying we're actually finished taking data from this observable. So now, if we come back over to here and reload, done, 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 and then finally when done is going to be set to true on the payload 9, it says complete. Now, of course, that did not go all the way through because our done on number 9 said, hey, we're done. But coming back over, you can see we're able to take that data, and then once we received all the data that we wanted to take, it then triggered the complete operation, and the complete function ran here. So the question is, what happens when you subscribe many times to the same observable object? A lot of folks get confused about this. If you work in the world of promises, let's say you call .then on the same promise over and over and over again. Well, that promise will only resolve or reject one time. So once the promise resolves, even if you call .then again, you get the same result you did from the original resolve. Observables do not behave that way. Each time you call subscribe, it basically fires off that same observer function all over again. Now, if you're using a helper method, you don't actually see the coding of that observer function, but if you're using the observable.create approach to create your observable, you actually write the observer function. And you will observe with the observer function that each time you call subscribe, that observer function executes again. So when you subscribe to an observable multiple times, you are literally firing up, 2, 3, 4, 5 different subscriptions that are not related to each other at all. This is important because let's say you actually do use observables to make a REST service call. If you actually call subscribe twice, you'll make 2 REST service calls, which is not what you would expect, especially if you come from a promise background. But keep that in mind. Each time you call subscribe, it refires up the whole chain all over again. Now, there are ways to set this up so that you can actually have multiple listeners on the same observer function invocation. And this actually brings up the topic of subjects, which we're not going to get into in this video. But it is possible to have multiple listeners. But for our purposes right now, each time you call subscribe, it's that one subscription connected to that one invocation of the observer function. And if you call subscribe multiple times, you get multiple invocations of that observer. Let's do a demonstration now exploring and understanding multiple subscriptions. Let's go ahead and take a look at what's involved for actually making multiple calls to subscribe. So now what we're going to do is we're just going to copy this right here, paste that, we'll rename that to managing subscriptions. Okay, so let's go ahead and take this code out of here. And let's go ahead and use our code here. And we'll take that out. And we're going to kind of simplify this a whole lot. And we're simply just going to have our set interval, subscribe, receive a value, and we're going to get rid of all these other functions. Now, what we're going to do is we're actually going to set up 2 subscriptions. And I want you to observe how often this observer function executes. In fact, we'll say let observer function invocation counter equal to 0. Now, each time we call this, we will increment it by 1, and we'll actually output that value here in our console log. So now let's come into here and reload. Invoked observer function 1. Wait. So we invoked it the 1 time. Now let's set up a second one. So we'll say subscribing 1, subscribing 2. And I'm going to increase this actually to 2 seconds so we don't get so much data in the console. Reload. Notice the observer function was invoked twice, once for each subscribe. So they're actually each receiving their own set of values. That's why you see 1 and 1 and 2 and 2 and 3 and 3. Those are separate data streams. They are not sharing the same data stream. Those are separate data streams. In fact, if we wanted to, we could come into here and we could actually take the value being emitted, this next, and we could actually multiply this, and you'll see that one set of values is always doubled, and then one set of values is not. So we'll paste that like that. So what we can do here is actually set it up so we can multiply it by the counter. Now, in order to do that, we're actually going to have to save a reference here. We're going to have to say const my counter is equal to, and we'll actually need to do that after we do the increment. There we go. Then take the my counter here, and you can just multiply this down here. So save that. Come back over here and reload. Now take a look. So you can see now 2 and 4, 3 and 6. See how there were different observers are being used here. All right, that's not the same data source that's populating it. So So each time you call subscribe, it re-invokes that observer function again. As we've learned in this video, observables are a great way of handling streams of asynchronous data. A popular library for working with observables is RxJS. Now, observables can be created many ways. If you want to do everything custom, you can use the create function available on the observable object. You could also use numerous helper functions, such as interval, of, and from event. Observables can throw errors. They can also run forever, or they can run for a certain period of time or run for a certain set of data. If you want to be notified when an observable completes, then you can pass in a complete notification function to your subscribe. If an observable never completes, then you must unsubscribe from it, or if you want to stop listening before it's completed, you can unsubscribe, and we do this to avoid memory leaks. Now, each time subscribe is called, you actually get a new instance of the observable. The observer function runs again, and each one is a separate instance of that observable.